Okay, hello everyone. Another session. Today we discuss inter-VLAN routing. So after we did VLANs, we saw there is need for communication between two different VLANs. We realized there can be communication within the same VLAN because it's the same network, it's basically the same network. But we cannot have communication between VLANs if we don't have a router or a device with routing capabilities connected to our network. So basically, that's the idea around inter-VLAN routing. Um, Objectives of the course, methods of implementing inter-VLAN, how to use routers to implement inter-VLAN, how to use layer 3 switches to implement VLANs, and how layer 3 packets are forwarded. That's basically what we're going to be discussing. I think this is going to be a very short session. One 30-minute video should be enough. Inter-VLAN, um, real network deployments, different IP addresses are assigned to different VLANs, PC on the same segment, in the same VLAN directly communicate. So basically, what we have here, we have my switch here, and we have configured our VLANs. You can see this device and this device, both these devices and VLAN 10. Then we have other devices here in VLAN 20. So the idea around inter-VLAN is to allow communication between two different VLANs. So if you configure your VLANs, communication between these two devices, it's okay. You can do that between just by using a layer 2 device. Communication between these two as well, you can use a layer 2 device to do that. But for communication between VLANs, you cannot have it by only using this layer 2 device. So what you will need a device with routing capabilities like a router, which will allow communication between VLANs. Therefore, the definition of inter-VLANs. That device could be a router, it could be a layer 3 switch, it can as well be a firewall. Um, then configure, how we ensure, how we can have inter-VLAN routing with different ways that we can have it. One, we can use a router's physical interface to have our routing. So basically what we have here, if you take a look, we have devices in VLAN 10 here, a device in VLAN 20 here. This is our layer 2 device, our switch. If we don't have this router, we don't have communication between VLAN 10 and 20. So by using physical interfaces, we are basically creating two gateways using two physical interfaces for the respective VLANs. So for VLAN 10, using this connection, this connection will be used as the gateway and the connection for VLAN 10, and this one will be used for VLAN 20. Communication wise, how will our communication happen? If I want to communicate with a device from VLAN 10 to VLAN 20, traffic yangu inoyapa switch, it gets tagged with VLAN 10, then yoshandisa this interface, this link kuti isvike kurouter. Router rotates some routing table, then router kuendesa to this other interface, then yoshandisa this path kuti isvike ku VLAN 20. So basically here we are using two interfaces, two my interfaces per router edu, the physical interfaces to allow for communication in my interVLAN, between my VLANs edu. Problem is, however, issue is scalability. This solution is not scalable because how many interfaces, physical interfaces, will you need to allow inter-VLAN routing? Panapa tine two VLANs. Therefore, we need two physical interfaces. What if we have 30 VLANs? Will you have a router run 30 physical interfaces? Or will you need to connect to multiple routers with multiple physical interfaces for you to do that? That's where the issue is. This one, therefore, is not a scalable solution and it's not as readily used um, in networking, although it's an option. Then we have another one, the router honest. Okay, Huawei is not router honestic. It's by using routers sub interfaces. So instead of using the physical interfaces, multiple physical interfaces, we create my sub interfaces on one physical interface, on one physical interface. So here, same idea, VLAN 10 and 20, we need communication between these two VLANs. But now we have one physical interface. So this is one physical interface, this one physical interface. But within that physical interface, you create what we call sub-interfaces. So you can see there's a sub-interface runs .10, there's another sub-interface runs .20. So the idea remains the same. The idea of inter-VLAN routing is for every VLAN, you have a gateway for every VLAN on a router. So per network communication, a VLAN communicates with its gateway. Rikakommunicate negateway raro, router rozoita routing, then tokwanisa kuita communication between VLANs. So the idea remains the same. With the physical interfaces multiple, we have multiple interfaces, physical interfaces, creating multiple gateways. Therefore, inter-VLAN routing yedu yapo. With this one, it's one physical interface with multiple sub-interfaces. So this one is a bit scalable because on one physical interface, we can create multiple sub-interfaces. Sub-interface processing. So probably here they're getting to explain how the sub-interfaces work. Device in VLAN 10, device in VLAN 20. We want communication between these two devices, VLAN 10 and 20. How the communication happens. PC sends traffic to the switch. This ports tags VLAN 10. VLAN 10 connects with its sub interface. Here, this sub interface allows the router to connect to to get access to the router. Then we can access the routing table. Turn on the destination and VLAN 20 group. Destination and VLAN 20 allows us to push to this interface. Traffic yedu ikasvika panapa, then inokwanisa kudzika. That's basically what inter-VLAN routing is. Example of configuring my sub interfaces. This is how my sub interfaces are configured. So on a physical interface, this is how one physical interface is. This one. Physical interface rate is gig 001. It's highlighted panel. Right. So to create a sub interface using this command, interface gig ethernet 001.10. .10, you can how do I put this? You can synchronize my VLAN IDs ako, synchronize, align my VLAN IDs ako nema numbers or panapa. So if you see a .10, it's usually because you are aligning this with VLAN 10. .20, VLAN 20. It's not necessarily, it doesn't necessarily mean within the 10 up. I can align it with VLAN 10. So you can align it with VLAN 20, but it makes sense to guys at .10 panel. Then align that with VLAN 10 so that documentation gets much easier. So this is how you create a sub interface. Then sub interface can create you have a command.1q termination VID 10. That command is the command which associates a sub interface created with a VLAN. So panapa in ndikauya ndikati VID 10 it means sub-interface create apa here. I'm associating it with VLAN 10. So traffic VLAN 10 gonna achieve from our switch in where to this interface because I've associated it. Then this one, you assign an IP address to your sub-interface. Then basically that's it. Kana wadaro configuration sub interfaces yako yatopera. Then you configure another one, .20, you do the same thing, you assign an IP address, then inter-VLAN routing yedu yakutoitika. It's as simple as that. The last one, another method of inter-VLAN, I think this one is probably the most efficient, is the one we use a layer 3 switch. So a layer 3 switch is a device which has my capabilities of switching. That's layer 2. It also has my capabilities of routing. That's layer 3. That's probably why it's called a layer 3 switch. It can both switch and route. So instead of having my methods that now you realize that they were using a switch and a router. Instead of having two devices, because you need this for inter-VLAN routing, then you need this for creating your VLANs. Instead of having two devices, we could replace both of them by one device, which does both the jobs of those two devices. So a layer 3 device can be used for inter-VLAN routing, and the idea of how it works, it remains the same. The idea of inter-VLAN is to create my gateways for every VLAN. Every VLAN run a gateway rayo. Gateway iroro ndo richatora traffic from the specific VLAN roendesa kurouter, then router router to inter-VLAN routing yedu. So in this case, how we achieve that? How we achieve that? We get into by example direct. How we achieve that? We configure those virtual interfaces, VLAN interfaces in this case. My VLAN interfaces. So basically, you align my VLANs akwa nema interfaces on also creator, my virtual interfaces on creator on this layer 3 switch. So for example, the VLAN 10 panel, do not create a virtual interface yangu inonzi 10 panel. Ndobva assign an IP address. So what will it mean? It means every device in VLAN 10, it will go to this virtual interface kana paunoitika inter-VLAN routing. This will basically be the default gateway for every device in VLAN 10. How we do that? These are the commands you configure the visual interface. So for VLAN 10, I can enter this interface VLAN if 10, then I assign the IP address. For VLAN 20, I also assign the IP address. Kana daiso ndatopedza iri ndorinenge default gateway VLAN 10, iri ndori gateway VLAN 20. These are virtual interfaces, not physical interface, not physical interfaces. So communication-wise, how will the communication happen? Traffic can head over from VLAN 10 to VLAN 20, in over panel, you shake up a port iri, it gets tagged VLAN 10. VLAN 10 ndoendesa default gateway my virtual interface irapai yasvika virtual interface, then yonotaswa routing table to destination ichi yobva yarautwa yobva yaendeswa with this interface. This interface robva radzosa robva raunza on this physical interface rine VLAN 20, tag rangu robva rabviswa, then robva raforwardwa to this device. That's basically how layer 3 switches can be used to perform my duties in inter-VLAN routing. The forwarding process, I think that is basically what I was trying to explain. Traffic yangu over from this PC, you end up a switch rangu, the switching module, radar tag, VLAN 10, then pusher to the routing module. This is my visual interface 10. Then routing ndio inokwanisa kuendesa kunoko. Kana enda kunoko inokwanisa kudzika apa tag robviswa, then information enda ku PC2. That's how inter-VLAN routing using a layer 3 switch works. Process number 2, probably a repetition of what we've been explaining. Process number 3, same difference. What I've explained, do a lot of wording against about. I think it's as simple as that. Layer 3 communication process. The last thing we'll do here, they were trying to explain how will VLANs communicate with the outside network. This is a typical network where we can see a traffic of a VLAN communicating with the outside network. So we have traffic from this PC, which is in VLAN 10, either we enter to this server. Server iri haisi munetwork medu. Hatomboziva kuti iri muVLAN here. It's not in our network in short. So how will traffic here in VLAN 10 get there? How it gets there, traffic in over pano, you go on this interface, you just take VLAN 10. You underscore ukoko. This is a layer 3 switch. Okay, this is another switch. Layer 2 switch here. So this is a layer 2 switch. So traffic here network take, you underscore kunoko. You scapan up. Probably this will be a trunk. Yaskapano, you end up to the visual interface here, VLAN 10. Visual interface here, VLAN 10, download as a routing table. A routing table, you get traffic rufa outside this interface. You Buddha, you seek up a router. Traffic peru Buddha, effect traffic peru seek up a VLAN interface app. Is a route kwa. It no longer belongs to your VLAN. Traffic kana yako routing. Akusisina chinhu VLAN. Routing is layer 3. VLAN is layer 2. Kana takutaura nezverouting akusisina chinhu chinonzi VLAN. So traffic yedu payakutosvika at this stage apapo. VLAN redu hapasistorina. Hatichataura zvekuti iri VLAN 10 kana kuti iri pai. VLAN redu rinoshanda kana tiri kumalayer 2 devices tiri kwekoko. The traffic yedu yosvika on this interface, then it gets routed via our service provider kusvika to this server. What's key in our configurations is probably how you need to configure this interface. Because we've already done that. Kunoko, layer 3 device rango, let me clear this so that I can restart. So communication-wise, how communication can go from a device in a VLAN to another device outside the network without a VLAN that we know, that's how it happens. But what's key is knowing kuti panapa ndichacreate our VLANs 10 and 20. Panapa ndopane inter-VLAN yangu apo, layer 3 inter-VLAN. So ndichacreate ma virtual interface yangu VLAN interface 10 ne 20 ndo ayarapa. Then this interface will need to be configured for routing. It will need to be enabled kuti reconfigure kuti rikwanise kurouter. By default, a layer 3 switch mapos acho ese anenge ari switching, meaning they cannot route. They exist at layer 2. Routing yedu tinokwanisa kuita kana tichishandisa visual interface. Visual interface anokwanisa kuita routing. But kana takuda kurouter using physical interfaces, they will need to be enabled to allow them to route. So since it is reconnected to an interface, router to this router, this will need to be enabled for routing. So panapa pafanira routing panapa interface iri kufanira routing. Then kana tasvika panapa, this is basically LAN redu riri kunoku. Kunoku ndo our public network. So they introduce something briefly to you. We have NAT, another technology, a protocol that used to translate your private IP addresses from the LAN to public IP addresses over the internet. And basically, that's what is being explained over the next few slides. No communication is going to press up, press up, press up. And we are done. That's interVLAN routing. For the quiz, I will leave that to you. Probably what I can do is summarize what we've done so that we can see this is very simple. InterVLAN, inotangira panapa. Ndine switch, iri VLAN 10, device iri VLAN 10, iri VLAN 20. Let's put another one, iri VLAN 10 as well. So communication between this device and this device, it can happen on this switch. But communication between this device and this device, it can never happen. Why? Because these are two different networks. Two networks unconcentrated communication if there is a router. So to solve that, we introduce a router, VLAN 10, VLAN 20, introduce a router. Router rangu rine two physical interfaces akakonectwa. Iyi ndoinanzi the legacy way of communicating of interVLAN routing. So communication wise, what will happen? VLAN 10 iri rinolingwa this interface. VLAN 20 rinolingwa this interface. So kana ndoda communicate between my VLANs, traffic yangu inobva apo yosvika apo, then yorautwa youya uko, then yodzoka kunoko. That's how our router will work, using multiple physical interfaces. Another way, you can use one physical interface. One physical interface, but you create sub-interfaces panel. So I can create sub-interface 10, I can create sub-interface 20. My sub-interfaces angle, they basically act as my gateways for my VLANs angle. Communication-wise, if I want to communicate between 10 and 20, how will I do it? I'll go to this switch, then I'll go to this sub-interface, then routing it to this sub-interface, then it will go to this device. That's basically how routing will work. Then the last one is interVLAN using a layer 3 switch. I have one device which performs both switching and routing. So panapa, I don't use the physical interfaces. No, I use my virtual interfaces. So I create my VLAN interfaces for 20, I create another one for 10. So communication-wise, how will our communication happen between VLAN 10 and 20? 10, inoyapa interface yedu apo iswa tag, then yoyapa virtual interface rangu, then yorautwa kuenda pa this, yodzoka panapa tag robviswa yoya panapa. That's how we have communication between my VLANs. This is the skeleton for interVLAN routing. Thank you very much. Any questions? If we don't have any questions, I think we're done with our interVLAN routing. Thank you very much for your time.